And so it's much easier to pick this out and just sort of general web sort of text. And there's been some very recent research along these lines that may still be going on. There's a NSF CIA Knowledge Discovery Dissemination Program where Madigan and others at Rutgers at DIMAX were looking at this authorship attribution problem. And there was a related projects funded by the same program at USCISI, I believe. But another area that I've also considered, and I haven't done any work in this area yet, but automatic genre detection. Is there something about this misleading text, say of the Jonathan Levitt sort of text, that you could pick out and differentiate it from just the typical exaggerated day trader kinds of postings? And there was work 10 years or so ago by Schutz and Nunberg at Xerox PARC looking at automatic genre detection, for example. And I've talked with researchers at PARC more recently that they've told me that things on the web have gotten sort of much less crisp, more of a mishmash, they said. And so they're not really calling it genre detection anymore, but they're doing something like they call a sort of authority analysis or some such. But in any case, here you're not looking for the style of an individual author to identify the author, but rather just maybe there's something in this deliberately deceptive writing that you can pick up that would distinguish it from, just more general enthusiastic reporting about something, but it's not being deliberately deceptive. So towards the end of this project, we came up with a prototype, and we were interested in developing this countermeasure for misinforming news. So we assume that there's an end user who finds a possibly misinforming news item or discussion group posting. And again, this is sort of a pump and dump scheme kind of thing where if this is reliable information, the user could make a huge profit, but otherwise might lose everything. So we allow the user, in this case, to automatically generate a query from the text of the item, and we submit it to the Google News API, which then issues a query and comes back with maybe a few hundred or a few thousand textually similar news items. So we consider two different countermeasures, and one we call the news verifier. So the idea with this prototype was that stories would be optimally re-ranked and presented to the user. So Google comes back with some ranking of the news stories, but this is a ranking based on whatever algorithm that Google is using, but it's not a ranking designed for the purpose of detecting misinformation in the original story. So in any case, if you could come up with an optimal ranking of stories which would most likely assist the user in determining whether the original story was misinformation, then you could sort of leave it up to the user. So if you could, in your top, few, 2 or 3 ranks of the re-ranking, assist the user in that way, then this countermeasure could succeed. If, on the other hand, in your several hundred returned items, the ones which would really be most useful for the user were back there in ranks, 110 or something like that, user's never going to see them likely. So that was the first countermeasure. The second countermeasure, which we didn't get to implement because funding ran out at that point, was starts the same way. So you send off the query to the Google News API. It comes back with a collection of similar documents. But here the idea was to automatically analyze these rather than just showing a ranking to the user, and use something like the information trajectory model I described. And so in this approach, we would assume we have access to stock market price movements. We would be able to extract the ticker symbol from these news stories for the company and see if the movement of the stock price looks like it's out of line, implying that some manipulation was going on. So our experimental design was then to see whether the first countermeasure or the second measure would work better. And we got a set of data from University of Massachusetts Amherst, and there's a URL at the bottom if you're interested in this project. It was called eAnalyst. are an electronic analyst of financial markets. And then this originally started as a student project in a class at UMass, and they wanted to use it for stock market prediction. So they had a data set of news stories for about 9 months, around 2000, I think, and there were 121 publicly traded stocks that were mentioned in these news stories. There were ticker symbols in each story, and they had the stock market prices during the same time period for these 121 companies. And this was from the Center for Intelligent Information Retrieval, UMass Amherst. And so they used a data mining algorithm, something called activity monitoring, that was used for cell phone fraud detection, developed by Fawcett and Provost, where they're monitoring the behavior of a large population of interesting events like cell phone fraud requiring some kind of action. And they were applying this to this sort of stock market prediction. And so they were able to look at this as a time series because they had the timestamps on the news articles and and the stock market price and so on. And I guess going back here to this project for a minute. So in my own earlier research, I developed an algorithm for probabilistic information retrieval that would be called like a Metasearch algorithm in today's sort of terminology. So we implemented the Lucene open source search engine and the Lemur probabilistic language modeling approach to information retrieval system of CMU and UMass Amherst, and combined those two. So we had this original set of documents returned by the Google News API, the Google ranking, the rankings of these other two search engines. We used my combination algorithm to get a combined ranking, and you could then, if the user was willing to take that long to do it, have the user provide relevance judgments for the first few documents looked at and use those to adjust the weights and do a re-ranking. You could also use this sort of machine learning algorithm to learn over time. And in this way, you could, determine, you could sort of, I guess your system could adapt to, produce rankings that were optimal for, doing this disambiguation rather than just the sort of relevance-based, for the purposes of document retrieval algorithms that presumably Google, Lucene, and Lemur use. Okay. So now broadening the scope of this work, another area besides these sort of pump and dump schemes where there's interest in this kind of deception is in the intelligence community. So there's this idea of denial and deception. So, for example, there's the Foreign Broadcast Information Service, which collects news from around the world to support open source intelligence analysis. And clearly misinformation could be planted in these stories intended to mislead analysts. And in more recent years, the FBIS is going beyond traditional sources of broadcast news and text and so on to collect more and more information from websites. And so, again, there's more chance for this sort of denial and deception and an interest in being able to detect this deception. Then, starting in 2003, the National Science Foundation and the National Institute of Justice started a new annual conference called the Symposium on Intelligence and Security Informatics. And the rationale behind this was, just as we talk about things like bioinformatics or medical informatics, they claim we need a new scientific discipline of intelligence and security informatics. And I've been involved with this conference and only attended the first one, but at the first one, there were keynote speakers that were associated with the same program I mentioned earlier, the Knowledge Discovery and Dissemination. And so with my background in document retrieval or information retrieval, it occurred to me that what would make this kind of informatics, one of the key factors that makes this difference from traditional, say, legal or medical or scientific informatics is, while you have occasional fraud in science and so on, for the most part, you take information at face value.